Yes.
Greetings and welcome, ladies and gentlemen. We're talking page 115, linear programming again. We're going to take a look at questions 7 and 15 in this video. So it says, Woodland Bicycles makes two models of off-road bicicletas. The Explorer, which sells for $250, and the Grande Expedition, which sells for $350. Both models use the same frame. Alright, so this is similar to a problem we did yesterday, I think, in class. The painting and assembly time required for the Explorer is 2 hours, while the time is 3 hours for the Grande Expedition. There are 375 frames, 450 hours of labor for production. How many of each model should be produced to maximize revenue? So how many of each model? Right, so my variables come from the question. So I'm going to say that X is the number of Explorers produced, right? Explorers. And Y is the number of Grande Expeditions, right? Bam. The Grandes. So, to write our equations, or inequalities most likely, let's see. I know one equation I'm going to write is regarding the number of frames available. And then the other one I'm going to write is going to be regarding hours of labor. So my equation regarding the frames, what do I know about the frames? 375 frames altogether. So the number I produce must be less than or equal to that number. And yeah, straight X plus Y, no matter how fancy your bicycle it is, it should only use one bike frame, I imagine. I would expect. So, let's see, hours of labor. I know there's 450 hours of labor. So I've got to use less than or equal to that. And in this case, even though it says painting and assembly time, they actually didn't separate those two. They didn't tell me how many hours of painting and how many hours of assembly I have. They just gave me the total, so it actually doesn't matter. So it looks like it'll be 2 hours for each Explorer and 3 hours for each Grande Expedition. Okay, so no discrepancy so far. And then my last two equations is I can't have negative amounts of bicycles for each. So, and you still got the wrong answer for this one?
Yes. That's weird.
Well, let me investigate a little bit further then. I didn't give myself enough room to do this for realsies, but let's see, if I solve the top equation, I'd get y is less than or equal to negative x plus 375. And the other one, after solving, I'd get y is less than or equal to negative 2/3 x plus, what's 450 divided by 3? 150?
Yeah.
Okay. All right, let me give these a little graph real quick then. Why not? Open up Geometer's Sketchpad. Here we go. Let's see, let's get a grid showing. So based off of my results, I'm expecting, let's see, I've got to go as high as 375 at least, right? It's my highest y-intercept here, so, oh, that's cool. I realize I just accidentally made a rectangular grid rather than a other way square grid, but that's fine. So 375, so that should be good. I'm going to graph, let's see, I'll go out that far. Actually, I definitely have to go out to 375 on each. Maybe, can I switch it back to square grid? There. Now it controls each of them simultaneously. There we are. So let's graph a new equation. So I'm going to have negative x plus 375, bam, right there. And then graph negative 2/3 x plus 150, bam. Oh, this one's interesting. And then I've got my vertical and horizontal equations. Now, both of these equations, it had to be less than those. Am I right? So the common shaded region is actually just the smaller triangle. That means that the outer boundary actually has no limitations on this. So this is it was still a constraint, but it ended up not being very constraining, or at least not as much as some of the other ones. So so that's kind of an interesting result there. Let's see. Let me hide those, and I'll snapshot this. Snapshot, and I'll paste that in there. So yeah, I end up only being interested in the lower shaded region because the upper one ended up, that top thing didn't end up affecting it all. And then I would have found my A, B's, and C's. So I don't know, A, B, C, or something like that. So this A would have been 0, 0. B would have been 0, 150, and C, might have to calculate C. I know that the y coordinate is 0, and it's the x-intercept of that one. So if I plug in 0 for y here, I'd get 2x is less than or equal to 450. So to solve, I'd have to divide 450 by 2, and I'd get 225, comma 0. And I believe the correct answer ends up being the 225, comma 0. So C ends up being the optimal solution when you plug those in your profit equation. Which, I didn't write the profit equation, or revenue equation, sorry. R of x, comma y was equal to, what was it? 250, 350? So 250x plus 350y. So it turns out that even though you make more revenue for each of the Grande expeditions, this is actually suggesting that you make none of them to optimize revenue, which is interesting. But anyway, so that is an interesting graph result, so I'm glad we did take a look at that. Let's see, I'm just going to do the setup for this next problem, so I'm not actually going to solve it. Miss Carlisle has written a final exam for her class that contains 2 different sections. Questions in section 1 are worth 10 points each, and questions in section 2 are worth 15 points each. Her students will have 90 minutes to complete the exam. From past experience, she knows that on average, questions from section 1 take 6 minutes to complete, and questions on section 2 take 15 minutes to complete. Miss Carlisle requires her students to answer at least 2 questions from section 2. Assuming they answer correctly, how many questions from each section will her students need to answer to get the highest score possible? I like this. So what's the question? How many questions from each section, right? So those are my variables. So I'll say x is the number of questions, right, from section 1, right? Right? And then y will be the number of questions from section 2. Right? So for our equations, let's see. What do we have? What types of information do we have? We know the points of each, so that's going to be our score equation, is going to be our thing we're maximizing. I know the time. Right, so I've got some time limitations. I also know her requirement for the minimum number of questions from section 2. Min questions, section 2, right? Are those kind of all 3? I think those cover all of it. So let's see. So my score equation, x comma y, I get 10 points for every one from section x and 15 from section y. So that's the equation to be maximized. Now my time constraints, I've got 90 minutes total. So students have to answer all of these in less than or equal to 90 minutes. So let's see, section 1 questions are 6 minutes, so 6 minutes times every section 1 question, plus 15 minutes for every section 2. Okay? And then she requires her students to answer at least 2 questions from section 2. So section 2 has to be at least what?
2.
Greater than or equal to 2. And then I have probably one other constraint is that they can't answer a negative amount of questions from section 1. Right? And I think I've covered everything from this. And then you would solve this, maximize the score, and apparently the answer was they should answer 10 section 1 questions and 2 section 2 questions after it's all said and done. So good stuff. All right. So thanks, internet friends, for watching, and have a great day.